Yes, next we proceed with Lenz's law, and the statement is given by the polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic force that produces. मतलब कि for example यहाँ पर देखो, there is a bar magnet and a circular coil. When a bar magnet is moving towards the coil behaves, or in the coil the current is induced in an anti-clockwise direction. That means this coil end will behave as a north pole of a bar magnet. अब ये नॉर्थ पोल ही कैसे इंड्यूस हुआ तो सी अब इस स्टेटमेंट का मतलब पता चलेगा. सपोज कीजिए कि ओवर यर साउथ पोल इंड्यूसेस, लेट अस कंसिडर इन अपोजिट मैन कि नॉर्थ पोल, when the north pole of a bar magnet is moving towards the coil, it induces south pole. Then can I say north and south will attract each other? So if I give a gentle push to this bar magnet and it suppose induces a south pole, so south pole will attract the north pole, and due to attraction the coil or bar magnet will accelerate, मतलब velocity increases मतलब kinetic energy increases. So this violates the law of conservation of energy, means with a little amount of mechanical energy we are getting a more amount of kinetic energy, so that violates law of conservation of energy. So the north pole of a bar magnet when moving towards the coil, it induces north pole, so north repel. So for entering more number of magnetic field lines from this coil, मतलब increasing the magnetic flux, we have to push this bar magnet more. That means we have to apply more mechanical energy. Then and then only more number of magnetic field lines will pass through the coil, and its magnetic flux increases. So that obeys laws of conservation of energy. So in short we'll remember कि नॉर्थ पोल जो है वो जब नॉर्थ पोल बार मैग्नेट का कॉल की तरफ जाएगा तो ही नॉर्थ पोल इंड्यूस होगा. जब नॉर्थ पोल दूर जाएगा तो अपोजिट पोलैरिटी इंड्यूस होगा साउथ पोल मूव होगा टुवर्ड्स दी कॉल तो साउथ पोल, और साउथ पोल मूव अवे होगा तो नॉर्थ पोल. तो दैट इज लेंज़ लॉ. यानी कोई भी अगर पोलैरिटी ईएमएफ का या इंड्यूस ईएमएफ या इंड्यूस करने का पोलैरिटी जो इंड्यूस होगा वो उसके कॉज को हमेशा क्या करेगा, अपोज. दैट इज लेंज़ लॉ. Now Faraday law जो है that gives magnitude of induced EMF or induced current, and Lenz's law gives direction of induced EMF or induced current, and it is also based on law of conservation of energy, जो मैंने आपको पूरे ये डायग्राम में समझा दिया. Clear? Now next topic is motional EMF. But for that we consider first of all this diagram. Consider this green color as a rectangular coil. On this rectangular coil we are placing one conductor rod PQ. This blue color cross represents a magnetic field, uniform magnetic field going inside the plane of paper. ठीक है. So ये जो blue color के cross है that are uniform magnetic field which are going inside the plane of this board. This green color is a rectangular coil on above which we have placed one rod PQ, conducting rod PQ, whose velocity is this direction towards the left direction with a velocity vector v vector. Length of this PQ rod is L, and it is displaced from, consider from this position to this position, so displacement is x. Clear? So consider a rectangular conductor PQRS placed in a time independent magnetic field. मतलब time independent of magnetic field means with increase in time the magnitude of magnetic field remains constant, so uniform magnetic field. A conductor PQ is free to move with a velocity v vector towards the left side. यानी ये conductor जो है वो move कर रहा है towards left side. Then now there is a no friction and loss of energy in moving the rod PQ. यानी रॉड PQ जब मूव करेगा इस रेक्टेंगुलर PQRS कॉइल पर, सो वी सपोज दैट देयर इज नो फ्रिक्शन एंड ड्यू टू विच देयर विल बी नो एनर्जी लॉस. This PQRS forms a closed loop whose area changes as PQ moves perpendicular to the uniform magnetic field. देखो मैग्नेटिक फील्ड इनवर्ड है, यानी z एक्सिस पे ले लो, तो रॉड जो है वो मूव कर रहा है अलॉन्ग x एक्सिस, तो परपेंडिकुलर हो गया. तो रॉड का मोशन परपेंडिकुलर है टू द मैग्नेटिक फील्ड. सो हियर आर क्यू यानी कौन, ये वाला पूछो वो कितना डिस्प्लेस हुआ x, एंड पी क्यू मतलब ये कौन, दैट इज एल. तो एज पर फैराडेज लॉ ई एम एफ इज माइनस डी फाई बाई डी टी, ये तो हम जानते ही है. ठीक है. So as per Faraday's law, EMF equals to minus d phi by dt, that is minus b into a upon dt. Flux is dA. Area of this rectangular coil is nothing but L into x upon dt. Now from this magnetic field constant, length of the PQ rod is constant, so variable is x. So derivative of x with respect to dt gives velocity of rod v. So EMF of this rod is given as E equals to minus BLV. This negative sign indicates presence of Lenz's law, and the most important part, okay, this EMF will induce only if B vector, L vector and V vector are perpendicular. Right now in this case we have taken B vector inward, matlab along the z axis, length vertical along the y axis and velocity horizontal along x axis. If this condition is valid, then and then only EMF will induce. And another point, why it is known as motional EMF, because over here EMF is induced due to the motion of the conductor, such that then and then only this EMF will be known as a motional EMF. Now in extra we'll find out the relation of time rate of change of induced EMF. The EMF is given as minus BLV. If you derivate both the sides with respect to time, so dE by dt equals to minus derivative of BLV upon dt. Again B and L constant, so taken out common, so derivative of velocity with respect to time gives acceleration. So time rate of change of induced EMF can be given as minus BLA. Clear? So मोशनल EMF तभी जनरेट होगा जब कोई कंडक्टर मोशन में होगा, तो उसके मोशन से एरिया यहाँ पर चेंज हुआ, एरिया चेंज हुआ तो फ्लक्स चेंज हुआ, फ्लक्स चेंज हुआ तो EMF इंड्यूस हुआ. ठीक है.